All right, and today's set of speakers are going to be from the Supercomputing SCinet's DevOps group again, but they're going to be focusing on a slightly different topic this time. Previously, they talked a little bit about the measuring and monitoring infrastructure. This time, they're going to focus a little bit on server management, configuration management using the Puppet tool. So we have three speakers. The first will be Benjy Grover from Lawrence Livermore National Lab, and then we'll have Greg Veldman from Purdue University, and then we'll have Paul Anderson from Puppet. So I'm going to turn it over to Benjy, and he'll kick us off.
All right, thank you. So yeah, I'm from Lawrence Livermore. I've been here for about 15 years. I've had many different jobs here, and I guess I shall say I do this DevOps stuff as a hobby on the side because my day job doesn't do any of these sorts of things. So let me see if I can get the slide to advance. There we go. So brief overview. Our team coordinates the server and statistics systems as part of SCinet for the conference show floor. So we have and I'll get into some of these details later, but one of the big pieces we run is a database that manages our connections and the entire structure of our network. And we work with other teams to do that, but we're sort of the keepers of a lot of that information to make sure that things get connected and things are talking appropriately when the show comes. For those that aren't familiar, we're all volunteers, and we set up this high-performance network every year. There are reusable pieces that we do, but we try new things every year, and that sometimes can put a strain on us. I think many of our teams like the dev side of us, not as much the ops. So we sometimes end up having late requests when we're in operations mode, which makes our job a bit stressful. But we plan for a couple years, we build it in a month, we run it for a week, and then we tear it down in a day. And we have people from various places. For those that don't know what WINS is Women in Networking Sciences, and that's I think it's an NSF-funded grant where we bring women that want to work on our team and learn more about networking sciences. Our services are largely around IT and measurement. And I should mention I'm from the IT side, so Ken Miller is on the measurement side. So if you have any questions about measurement, I'm probably not going to know much about them. He largely handles that with his half of the team, but I'll go over these just very brief here. So we set up DNS and DHCP and NTP and all these other services across the network every year. We get those set up, we get the things running. We have our intranet, which is a Django. We use a Django web framework to run that intranet with a Postgres database on the back end. And that helps us manage our users, our database connections, our meetings, any sort of persistent data that we want to keep, equipment. Some of it's transient data that we get rid of at the end of the year, but it is a production system that has quite a few users in it and quite a bit depending upon it. And so we spend a lot of time fixing bugs on that and running the system. We host VMs for people, not only for ourselves, but for other SCinet teams. We also tend to sometimes do more than just hosting the VM. We help them with software or OS issues. And then we have our customer request system, our connection request system for our booth interfaces. So that's an outward-facing system where people can come in and say, I have a booth on the show floor, and I want to have this sort of connection connected to your network so that I can run a demo or I can connect back to my home organization. And so we do that. It runs the invoicing, it runs the reminders. We integrate that with our contractor on the show, with the show that helps set up our show floor and all those sorts of things. So there's a bunch of moving pieces there that can make this quite complex. On the measurement side, you can see the tools that we use there: SNMP, SFlow, and NetFlow. We're running all these different tools to understand the throughput of our network, what sort of bandwidth issues or limitations we might hit. Sometimes it's eye candy, so we can see how much is actually traveling through our network and let people know the speed of that network. And every year we collect those statistics to see where sort of our high watermark was that we hit to understand what's going on. We do a fair bit of monitoring with Nagios. We have all these different booths and routers, the booths across the floor, our DNOCs, and trying to understand what might be going on there, because we frequently have issues in the show where somebody will come to us and say our network is down, and we want to try and understand what's going on there. Many times it's because they've cut the fiber under their booth, but other times other things show up, so it's nice for us to have as much information as we have. And then our displays for measurement that we have running. And then performance, I've already mentioned this, but we have Personar and Mad Dash and Personar Flock to compare and contrast information, understand what's going on. And I think that's about it for the overview. There's just a lot of moving pieces. There's a lot of stuff going on, and can be quite stressful during the show, but interesting to see how this. It's interesting to build an entire network from scratch and run it, and sort of have your hands on every single piece of it. So that's, I think, one of the funnest things. So I'll turn the time over now to Greg. I think he's going to talk about some of the challenges we face.
Yeah. Everyone hear me okay? Just a quick audio check here.
Yep, we can hear you fine.
All right, good. So as Benjy kind of alluded to, we almost run like two IT infrastructures. We have this kind of smaller one that's up year-round and is our persistent services, our database and our wiki and our help desk and the things that we use to kind of plan the network. And then we also run this other kind of entirely separate thing almost at the show to actually manage the network. And that's kind of what I'll be focusing on, because that's where a lot of the challenges we face lie, and that will kind of set Paul up really well for why Puppet is a good fit to help solve some of those challenges. So, you know, we have all the usual suspects related to running a large production high-performance network. All the ancillary services that are necessary to make that go, the things like DNS, DHCP, the time server, and you know, those are all things that need to be managed by someone, and so having a central place where the management and configuration is kept is really nice. And then in addition to those, we have many challenges that are kind of specific to SCinet because of the nature of the network, and that creates a lot of things that you wouldn't necessarily see on a site or campus network that's, you know, running all the time and that's kind of build at once an incremental change. So the first thing is, obviously, the network only exists for about 1 month out of every year. So that kind of limits our ability to do things on it. You know, it'll create a huge backlog when we bring it up every year of new changes that need to be pushed out that we've been working on for the past year, new patches that need to be applied, all the things that you normally do as part of network maintenance on an ongoing basis. We don't get to do those for 11 months because our things are sitting in boxes. Another interesting one that has been really helpful to have Puppet for, because this is a huge problem that we end up chasing every year and spending much more time on than you'd think. When the network comes up, it may be in a different time zone than when it's shut down. So that creates all sorts of interesting issues with respect to things that are getting displayed on panels at the show. For some of the measurement and monitoring stuff that we were displaying before, or that Benjy was alluding to before. And, you know, the management team doesn't like when all your displays are an hour or 2 hours ahead or behind one way or the other. Doesn't make us look like we have our act together. So that's something that we have to make sure we always get right, and has always been a huge problem in the past, and something that Puppet is helping us a lot with. Go to the next slide there, Benjy, if you will. Another thing, as Benjy said, this is all done by volunteer. So it's not like we have a full-time paid staff that's running our network. So we do have a pretty significant churn of user accounts from year to year, much more than you would at a site or campus. And so that creates issues with ensuring that new people get accounts propagated to the right places so they can log in and do what they need to do. Old people get accounts removed, all of that stuff that you deal with maybe a couple times a year in a regular organization. We deal with constantly when we bring the network up. Another one is, we develop in one place and deploy in another, and sometimes that's virtually and sometimes physically. As I kind of said before, we do have a lot of our stuff that's kind of down most of the time. Our team does manage to bring some part of its infrastructure up for at least part of the year when we have our code sprint, our big development process, but that's certainly not everything. So we're dealing with different environment when we are writing our code and developing these services than where it's actually going to run. And that can lead to complications. Another one is the physical aspect. It's obviously in a different place, different time zone from year to year. And again, that creates little headaches that you wouldn't necessarily think of if you were just dealing with a static installation. Another one, rapid provisioning. That's a huge thing for us. We build this network in a month or less from scratch, and so things have to happen quickly and get turned around very quickly. We don't have time to be at the show floor slapping new OSs on everything and typing yum update manually on all of our servers. When the servers come out of their boxes and get put in the racks, it's because we need those systems up and we need them quickly. And so we need to be able to do that in a timely fashion. Another one, preservation and documentation of last minute changes. As Benjy kind of said, these are very common. There are two primary times of the year when our code is in the biggest state of flux. One of them is when we do our internal code sprint, our development push, usually sometime in the spring or summer. But then the other one is the week or two right before the show starts, because invariably someone will come to us and say, oh, we're doing this thing different this year, or we're deploying this service this year, and sorry, we haven't told you about it. Could you support it somehow from the database? And so that's a huge effort where we've got a lot of code churn happening right before the show starts to try and get some of these late additions to the network supported and up and managed. It goes along with, like I said before, it being built in a month. It creates some unique challenges to have that done. Next slide. Another one, as I mentioned, a lot of our systems are down most of the time. So if we want to do development work, we kind of have to know what state we're starting from, which means we need access to the existing code. We need access to the existing configurations. A lot of times those things are literally in a box, a cardboard box or a warehouse somewhere, unplugged and powered off. So we need some central way where we can have and preserve those so that we can look at them when we need them when we're trying to do something in the interim. Another challenge, as I kind of alluded to before, we're constantly adding new features and functions. SCinet is definitely not static from year to year. Every year there's usually at least one major thing different that we do. A couple of years ago, we started getting into the software-defined networking. And this year, we're changing the way we manage taps for security, for example. So there's a lot that changes from year to year, and it's helpful to have a central place where we kind of know, where we've been and where we're going, so to speak, to see what we've done in the past and to be able to build on that work and know where we want to take it in the future. And so kind of a lot of those things, really speak towards having a central management system like Puppet. So I'll open up if anyone's got any questions for me. By the way, I'm from the IT side of the house also, like Benjy. I'm one of the primary sysadmins for the infrastructure. So if anyone's got any questions for me that I can answer, otherwise I'll turn it over to Paul.
This is Michael Lambert from Pittsburgh Supercomputing Center. Just a quick question on talking about NTP and the time. Why not just run SCinet on UTC?
That's been suggested. A lot of the reason has to do with the displays that are around the NOC and the DNOCs and other places in the floor. And there's the very strong desire to have all of those things display on the local time of the show.
Okay, thanks.
All right. Well, if anybody has any other questions, just type them into the chat. Otherwise, take it away, Paul.
Excellent.
Paul, I'll let you share the screen because I don't have your. You want to share the screen? You want to share your screen?
Yeah, I'm happy to do that. Just let
Okay.
me do that quickly. There we go. Okay. Okay, let's see if I can get everything to do that one. Okay, I assume everyone sees the how we do it slide?
Yes, sir.
Excellent. So we're going to start talking a lot about software and tooling, and I do want to begin this conversation by saying that it's really the talented team that we're working with. So Benjy, Ken, and Greg kind of lead the effort with a lot of contributions from a lot of team members. And really what the culture of the team is that we're focused on figuring out the solution to whatever the challenge is that Greg mentioned, and then automating it. Somehow we need to capture it, automate it so that we can carry it forward. When someone comes to the team and then maybe they leave the next year, we need to be able to say, hey, I remember that that person did something that was important and we need to remember it. And we're going to talk a little bit about how we kind of capture that. We follow an infrastructure as code model, and that allows us to sort of add to a growing body of good configuration rather than having to run around chasing fires trying to figure out if some specific script was run on some specific server, this year or not. And so to the talented team, we add tooling and a couple of DevOps philosophies and processes that I'm going to spend some time talking about. So the first one is infrastructure as code, and then we're going to talk about version control on top of that. Now, as mentioned, I am with Puppet, and clearly I have sort of that sort of relationship to a software product. But I did my best in these slides to speak kind of as generically as possible, and I only have one marketing slide. So please be aware of that. I'm trying to be as honest a broker as possible during this discussion. So let's talk a little bit about infrastructure as code. So the idea is that it's based on tooling, right? One could argue that if you check some Bash or Perl or Python scripts into version control, that's technically infrastructure as code. And I suppose that's technically true. But modern configuration management uses some tooling, and we're going to talk about Puppet in this case, but there are others out there that abstract away some of the difficulties of doing all of the little details of configuration management. And so with this infrastructure as code approach, whichever infrastructure as code tool you pick, it describes configuration in an objective way. So first off, it tries to abstract away the platform differences. So things, for instance, like the difference between Red Hat and Ubuntu using Yum versus apt for package management, between older versions of Linux and newer versions of Linux that use, for instance, System 5 init versus Upstart versus System D. And that's not even to mention things like Windows package and service management, AIX, Solaris, and other platforms that may be in use. And so by abstracting away those platform differences, it makes the infrastructure as code approach much easier, right? Imagine what it would take to write a Bash script that supported multiple platforms, installing and configuring, let's say, the SSH service and package and configuration. All of the if-then-else kind of stuff you would have to have in this hypothetical Bash script. Instead, our approach is to describe what the proper configuration is, and the underlying tooling will then make sure that it's properly configured for that specific platform that the code is running on. Additionally, we can abstract away certain configuration differences. So the idea that that some configuration files might be in JSON, some might be in XML, some might be in a sort of traditional .conf format. the infrastructure as code approach gives you the ability to work with that in sort of a convenient way and say most of this configuration file is perfect just how it is, except we need to make sure that we slap the correct time zone on, you know, line 37, character 3, or whatever the case may be. One of the things that's nice about this approach is that it's easier for that subject matter expert to sort of do the initial lift and say, this is how we're going to properly configure this or that application. And then once it's codified, then it's a little bit easier for others to maintain as appropriate, right? Getting it set up the first time is sort of the heavy lift, and then making sure that it's got the right configuration, the right time zone, the right domain name, excuse me, is pretty easy afterwards. And then another thing that's nice is that humans are very good at certain things, and computers are very good at certain things. One of the things that humans are not good at is these sort of repetitive tasks where you're doing the same thing over and over and over again. That's actually a perfect candidate for automation. And so once you've described the proper configuration, you can then use the tooling to confirm that that exact configuration, every single line is in the right spot, every single time zone is adjusted correctly. In our case, every 30 minutes, and if and when it discovers something unexpected, it'll go ahead and take care of it. So that's the sort of nice benefit of you write the code once, and then it keeps checking and double checking and triple checking that nothing surprising has happened. Oops, excuse me. So here is an example of infrastructure as code. Hopefully it's somewhat legible, but I pulled it out of an IDE and tried to make it a little screen friendly. But this follows a very traditional approach, which we call package file service. The idea is that if you want to configure something like SSH, you first need to make sure that the dependencies are installed, and then you want to make sure that you have the proper configuration file or configuration changes. And then lastly, that you're going to be running that the service is going to be running, and if it ever is stopped, to start it up again. Or if the configuration changes, maybe we need to bounce the service to make sure it's running the latest configuration. So this is very close to live code. I will admit in some of these screenshots, I have adjusted them slightly so as to not give information that could potentially be used against us in some way. Things like precise version numbers and stuff like that. But anyway, you can see that we're describing in a general way that we want to install the OpenSSH server, that it should be present, but we could also say that it needs to be a specific version number or the latest version or something like that. Once the package is installed, we'll jump down to line 10. We're going to make sure that that the file is configured, that we've got SSHD configured with our known good configuration from the source described in line 12, and we're going to make sure that that file is owned by root so that no one can kind of go in and adjust it. And so by describing the things that we care about, the things that we know are very important, then we can ensure that every 30 minutes, everything matches what we expect. And then if someone, let's say, were to go in and make a change to the SSHD config file, Puppet compares the MD5 sum of the file that's on the managed system and the file that's being reported by the Puppet server, so it knows whether or not it needs to overwrite the existing file. So in the case of a hypothetical time zone issue, we're going to know that the entire configuration is the same, except the old time zone versus the new time zone means that we need to overwrite the file. And then conversely, in this particular case, because SC16 was in Salt Lake City and SC17 is in Denver, they're actually in the same time zone. And so Puppet is not going to unnecessarily change the configuration files, because in this one case, we're not having that particular time zone issue on us. At least not for the show. We have the ability to set dependencies, and Puppet is aware of figuring out some of those. So you can see, for instance, on line 8 that in order to manage the SSHD service, we're going to assume that the SSHD package is installed. And we're not just going to assume it, we're going to tell Puppet this needs to be required. So do the one first, do the other second. And then lastly, you can see on line 15, we're going to notify the SSHD service anytime our configuration changes so that we bounce the service and make sure it's always running the latest and greatest. So that's kind of a simple example. It's something that fits conveniently on a screen. But if in your imagination you assume that we're doing something similar with our DNS configuration, our DHCP configuration, all of our security hardening firewall stuff, our web server config, LDAP, network, rancid, syslog, and all of the other things that Benjy and Greg have talked about, you can start to imagine that we have this sort of growing body of infrastructure as code that we can then add to year. And as we discover ways of making it better, doing it more efficiently, maybe we need to support a different operating system as we move from, let's say Red Hat 6 to Red Hat 7 to Red Hat 8 eventually, then we'll have this sort of existing infrastructure and we don't have to reinvent it each time we're installing a new system, as Greg mentioned. So to that, we add another concept of infrastructure as code, which is what we call a single source of truth. So in Puppet's case, we typically use YAML files to describe information that's going to be relevant to the configuration. And so we've got time zone and specifics here on line 34. We've got the show domain, because the domain needs to show up in a lot of places. And this is from last year. So clearly this year, we're going to update this line 36 to SC17.org. We're going to check it into the version control system and promote it through our testing process. And then by the end, all of the systems in production will be updated to say SC17.org in all the right places. There's some additional code above, but again, it's somewhat security related or potentially security related, so I've omitted that. But you can kind of get this idea that we have the infrastructure as code that describes how to do the configuration. And then as appropriate, we've got the single source of truth that says this is how the configuration needs to be applied. So, we're going to use this time zone, we're going to use the show domain, we're going to use this base, firewall configuration, we're going to use this, these logging servers, for instance. And so as Puppet, as this configuration gets updated, this source of truth gets updated, the data sort of flows through the code, the infrastructure as code that was written. And so this is one of the ways that we approach some of those challenges, like Greg mentioned, with respect to, for instance, the time zone or updating the show domain and things like that. So once we've got infrastructure as code, then version control very quickly becomes our friend. And the reason for this is that version control gives us a lot of benefits if we're able to describe our infrastructure as a series of text files, right? That's one of the things from the dev side of DevOps that really benefits what we're trying to do here. Excuse me. So some of the benefits that we get from version control come, for instance, from branching. So I think many of us have encountered a situation at some point where we go to edit a file and we look in the directory and we notice there's already a .back file. Or maybe it's a .old. Or maybe they're following sort of convention and it's, 2017, 10, 15 or something like that, .20, anyway. But the point is you show up and you notice that there's a bunch of these different configuration changes on your, whatever it is, httpd.conf or your resolve.conf, whatever the case may be. And so how do you then figure out what to do with all of those sort of backed up version control things? And so technically you could argue from the system operations point of view that is version control. But this is another sort of strength from the developer side of the house that can really give us a lot of benefits. So being able, for instance, to have a body of code, a very large body of code, such as what we're describing, and then make a branch of it so that you can test some changes to see if they do what you need to do, while yet letting production be production without stepping on the work that anyone else may be doing at any given time. So in this hypothetical picture that I've got here, you run git branch, and you can see that we've got the SC15 branch of code, 16, 17. We've got a feature branch called firewall changes that, in theory, I'm testing to see what's going to happen if we switch from this way of managing the firewall to that way of managing the firewall. And then someone is apparently working on a new rancid management approach or something like that. And so we can each sort of develop separately, and we can have a code promotion process the way that we might do with a software release, where after I've made my change, maybe I use version control to indicate that it's ready to go, and then someone like Benjy or Ken or Greg do a double check of my work. Maybe they ask me questions, and then once they're confident, they go ahead and promote that into the main branch of, in this case, SC17 code. And so now we have a process that says, we're not going to push changes into the main line of infrastructure, except that two sets of eyes have given it a thumbs up, for instance. And certainly there's other approaches to that we could do, but this is one that tends to work. Additionally, the Git tools give us a lot of benefits. We can config version, we can diff between config versions. So you can say, I seem to recall we made some major change in Salt Lake City with respect to DNS or something. So you can use the Git history to identify, what was the difference between SC15, SC16, and SC16 and SC17, and you can see, oh, well, that configuration actually hasn't changed, or perhaps it has, and this is why, or whatever the case may be. Additionally, using the source code control tools, you can go in and figure out who made what change to the configuration when. You've got a very clear idea of, you've got a very clear idea of what happened when. Sorry. So some of the benefits of this approach is that it leads to further DevOps practices. For instance, a continuation of the idea of using the right tool for the job, using CPUs, for instance, to do repetitive testing, whether they be unit testing or automation, and using the very talented team to identify, what should we do when to have increased confidence that changes getting, pushed through our infrastructure as code process won't have a negative impact on production during the show. Or for the other side, we've got one of those last minute changes. Someone comes and says, oh, well, we needed to use this network or add this or, whatever the case may be. So suddenly we make a change to the Puppet code. How do we very quickly gain confidence that it's not going to hurt anything? And so that sort of automated testing using a pipelining tool such as Jenkins or something like that can give us that confidence. Can identify problems before they become real. So this is the marketing slide as promised. So Puppet Enterprise provides some additional benefits. I've selected two pictures. One of them gives you a high-level view of your infrastructure so that you can get an idea and say how many nodes, for instance, had corrective changes, how many systems, Puppet managed something and then someone else changed it and Puppet put it back to where it was supposed to be. That's interesting for a lot of reasons. It could indicate someone doesn't know the workflow for change management, and so it's a teaching opportunity. Or perhaps upon investigation, it could be some sort of security issue. Or perhaps yet another possibility is that we updated some particular RPM, and that RPM update did something interesting we weren't expecting. So there's a lot of reasons why Puppet could potentially make a change to something that it didn't expect, and that's an opportunity for us to get insight as to what's going on in our infrastructure as code coverage. Additionally, the picture to the right is the node graph, and so this is the ability to dive in, and so as Puppet goes through all of this configuration and creates something that we call a catalog to say, this is the proper configuration from this system, pulling all the data, all the code. You can then dive into it and identify which resources changed, which had issues or failures, which had, which were interesting in some other way. So you can dive through and kind of get a graphical relationship to your configuration, identify dependencies, know what happens in what order, that sort of thing. And so lastly, I'd like to close with some statistics from the State of DevOps report. This is something that's done by Puppet and some industry research groups to understand what are the benefits of this sort of newer approach to configuration management. And basically what we find is that in traditional software companies, and I realize that our team is not a traditional software company, that it dramatically improves the number of changes going through the system. That rather than having a situation where we have to make 500 changes all at once and we don't necessarily know how they're going to impact each other, if we do those 500 smaller changes serially, then we can have greater confidence and identify more quickly any one particular problem. It also shortens the lead time, so if and when we discover we need to make a moderate change to the infrastructure, the ability to know that it's a small focused change, we've got some testing framework around it, we've got everything recorded, and if we needed to, we could push a fix through quickly, is very helpful. Additionally, if something were to go down, we need to make some sort of configuration change to fix it. It's almost 100 times faster than traditional approaches. And then lastly, a 5 times lower change failure rate, indicating that when you do push code into production, the odds of that code failing are significantly smaller. So between a really talented team and this infrastructure as code approach with some good tooling, we find that we're able to meet the challenges that Greg and Benjy described earlier in the talk. With that, let me go ahead and open it up for questions or comments.
All right, so thank you, Paul. So I'll put you on the spot. Is there any way that you can maybe show a live demonstration of maybe some of the dashboards or anything like that you've developed for SCinet? If you can't, that's okay too, but I'll throw it out there.
Yeah, no, I appreciate it. I will admit, we just finished our annual user conference, and so I only have canned slides at this time. I wasn't able to kind of prepare a workflow with the live console.
Okay, no worries.
Having said that, I am more than happy if anyone wants to during the show show you what the live console looks like, and we're working on getting some Puppet data into those dashboards that Benjy and Greg mentioned earlier.
Okay, so if anybody has questions, either shout them out or type them in. It looks like we have our first one that just came in from Yuri. We tried implementing a Puppet console before, a couple of times before. Both failed due to extreme resistance from end users. Do you have any suggestions about how to address that?
Absolutely. So, so when I'm not working with DevOps, I'm a professional services engineer, and I go on site and I help customers with things like infrastructure as code adoption, DevOps adoption, Puppet adoption. And one of the things that we frequently discover is that many organizations following sort of the traditional approach are very siloed, right? That the developers don't often talk to the operators, that the people who manage the base operating system don't often talk to the middleware people. The middleware people don't necessarily have, strong connection to the application folks. The audit folks are, of course, hated by everyone. And so very often I'm doing a couple things. Number one is that I'm trying to coach the management or the implementers of that approach, that they need to be careful when they just assume that technology will solve political issues. And the answer is that usually it's a matter of a little bit of discussion of cultural change and how do we actually get cross-disciplinary. Another aspect of it is that very often Puppet gets implemented on a sort of starting with some single team, and it's expected to kind of spread outwards. And while that is a very organic approach, and in many cases it can work, what it can tend to do if it's not implemented well is that for other organizations that aren't implementing Puppet, they have this sort of fear or uncertainty or doubt as to what's happening and how it's going to impact them. And so their initial viewpoint might even be negative because they have the impression that, Puppet is perhaps going to put them out of a job, automation is going to put them out of a job, or the team in question, going to the sort of silo mentality, is trying to expand their territory and conquer, other parts of the company or something like that, gain more power, as it were. And so one of the things I try to focus on when I'm working with customers in this sort of a case is using Puppet, using this infrastructure as code approach as a way of actually building trust and having clear demarcations between what's ours and what's yours and what's, what's mine, that kind of thing. So if you'll allow me to jump back in the slides just a little bit. One of the things we find is that having a team that can write the Puppet code, especially early on, is very effective because the application team is a subject matter expert with their particular application. And so letting the application team, I can't highlight. On line 12, for instance, you can have an understanding and agreement that says, for instance, we are going to handle the installation and making sure that it's running and that sort of thing. But we absolutely depend on you for the configuration, right? If I'm in operations, I probably don't know all the minute details of how to properly configure some, enterprise critical application that you've spent most of your career cultivating, for instance. And so being able to say, for instance, you're going to write the config file, and it's going to be infrastructure as code, so you have the ability to check that config file into version control, and you can check that config file into version control whenever you want. And here's, just so you're aware, sort of the pipeline process, we're going to take your config file, and we're going to automatically make sure that the software plus your config works. And as long as it does, we're going to put that into production, right? You don't have to call us, you don't have to, talk to us, whatever. But you have version control access to this aspect of your configuration, and you can own that. Additionally, if it's a little more complex, then we start talking about things like variables. So maybe they own the template where they know, the time zone goes here and this goes here, and then we just agree on what infrastructure information you need to properly configure your application, right? You need to know how many cores we have, for instance, so that you can have one helper process per core, or do you need to know how much memory we have so that you can properly size your virtual, like your JVM or something. And so you can, once you start having those discussions and you can help them paint a picture of how automation is going to help them and make their life easier, and that they will maintain control of this stuff that they need to maintain control over, then I find that eases the adoption. So I don't know if that answers the question or not, but I'm certainly open to do a little more discussion if you'd like.
Yep, it looks like that answered for Yuri, and he was nodding the entire time to his non-existent camera, so that's good.
Excellent.
We're going to answer the question about network taps offline because that's a little inside baseball and probably not of interest to everybody. Kate has a question. Do you use Puppet system to manage network switch configs?
So that is something that is undergoing active discussion. For SC17, it doesn't look like it's going to be that way, or perhaps maybe we'll try a little bit of experiments in a safe place. But for SC17, ostensibly, we're just working on the DevOps stuff, and we're talking to some of the other teams about potential benefits. So, for instance, the security team was interested in talking to me about some stuff there. And certainly the network teams have talked to me. We just haven't kind of picked the right approach yet between NetConf and maybe something Puppet specific and maybe some of the other stuff they're doing. So that is an active topic of discussion, but right now I'd have to say not yet.
I think bottom line is we'd like to. We just,
yeah, exactly.
Yeah, to go a little deeper there, right now, a good portion of the switch configs come out of the database because that's where we input all the different connections and VLANs and WAN circuits and everything that we have for the show. But that's a lot of very highly custom code that generates those and spits them out. And so there's been some, as Paul said, some discussions for a while on how to make that more generic and manageable and extensible.
So maybe a more general question related to that, and I guess I'll pose it to Paul. What really needs to be placed, or what needs to be present on a switch for it to be manageable by Puppet or really any sort of CF engine sort of system? It just needs to have sort of a visible API that the software can talk to.
So the short answer is yes. The long answer is it depends a little bit. So one of the things that we found as we've been exploring this is that if you pick a particular model of switch, you will likely discover that the vendor of that switch has released, 11 or 37 or 50 different firmwares for that switch that all need to be configured consistently. Otherwise, you'll discover that those APIs that you just mentioned behave strangely or differently across different firmware versions. And so that's kind of its own thing. Additionally, up until Wednesday, so as I mentioned, we just had our user conference. One of the new features that we announced in the latest version of Puppet is the ability to do things on a system in an agentless mode. So typically, Puppet has an agent that would need to be installed on the system, and that's provides some of that abstraction capability. And so there have been vendors, Arista, for instance, that essentially have a flavor of Linux or a cut-down version of Linux that's running on their switch, and so we're able to put our agent on their switch, and we can then sort of do all the configuration. Other folks that don't have that sort of a setting or a situation have been a little bit more difficult to work with Puppet. But as mentioned, now that we have the ability to interact with systems directly without requiring an agent, we're expecting that to ease the adoption curve of doing things like network device management, storage management, things like that. So that's one thing that gives me a lot of optimism for having infrastructure as code coverage for the switches over 2018. For SC18, for instance. But again, that's a sort of active development, discussion, investigation.
Okay. All right, we don't have any more questions coming in, but I'll just pause for a minute in case anybody does want to type them in. And thank all three of you again for making yourselves available today. This was really informative. So I will make sure that the recording and the slides do get posted for the people who were asking about that. And I'm not saying any more, so I think that with that, we'll call it a day. So thank you to Greg and to Benjy and to Paul again for that. And for those that are still listening, next week the talk is going to be from a good friend of the community, Matt Mathis. He's currently at Google, used to be at PSC, working with Michael actually. But he is going to be talking a little bit about BBR TCP. And I'll send out the announcement about that later on next week. So thanks again to everybody. Have a good weekend, and we'll talk to you all soon.